So first, for today, we're going to talk about section 5.6. So you're going to need to turn your workbook to page 150. And once you get there, we are going to make the list of all the theorems that we know so far to prove triangles congruent. So on the right there is the theorems to prove triangles congruent from yesterday and the day before that. We have side angle side, HL, which is only used in right triangles, but not the only option for right triangles, and side, side, side. Today we're going to learn about two more. The first one is going to be ASA, and that stands for angle, side, angle. So if you notice up here, it's pretty much the exact same thing as side, angle, side, just instead of two sides, it's two angles and the included side. So up here in the picture, I have angle A is congruent to angle D, and C to F, and notice that the sides that are congruent are the ones in between those two angles. So I'm going to have you draw this picture here for me. So go ahead and take a moment, pause the video, and draw the picture and write the question here. If you look at the two triangles, I have two right angles right here within the two triangles, as well as a set of congruent angles right there. So if you remember from yesterday, and I'll create a list down here in the corner of what is always true, no matter what. Really, we're working with reflexive and vertical angles that are always congruent right now. That's all we are really focused on and what we're seeing here recently, as well as the definitions of our vocab words. So definition of vocab. So these are my always true characteristics. If you look back up at the triangle, since I have two sets of congruent angles, can these triangles be congruent? The answer would be yes. No, I do not see three markings, but there is something in that triangle that is from my always true box. If you look at side BC here, both triangles share side BC. So that missing piece would be BC is congruent to BC by the reflexive property. But remember, when you're explaining if two triangles are congruent, reflexive is not a reason. A reason is one of the theorems to prove triangles congruent. So, in this case, we have now, if I mark that side, angle, side, angle. So this one would be by angle, side, angle. And I'm going to go ahead, and I accidentally cut off my space there, but go ahead and add ASA to your list of theorems to prove triangles congruent. Now the next theorem we're going to talk about is AAS, and that stands for angle, angle, side. So let's go ahead and add that to my list up here. I apologize that this is kind of sloppy. So angle, angle, side, what that is, if you look at the picture here provided in the workbook, I have angle A congruent to D, and C congruent to F. And if you notice, it's a side that is not included. Notice how the acronym is set up. It's two angles, then a side. So I want, when I trace my pen around my triangles, to be an angle marked, and then a side marked. So take a moment, pause the video, and draw the picture below, as well as the question, is triangle ABC congruent to triangle DBC. If you look at what we have one set of congruent angles here. A is congruent to D, as well as angle BCA is congruent to angle BCD. So what we need to think is, can these two triangles be congruent? What I start thinking of first is there anything from the always true box that I could say about this picture? If you look at this segment here, BC, I can say BC is congruent to BC because it is reflexive. Once I have marked that, if I trace my pen, I'm going to do it in blue here, around my triangle, I have an angle marked, and then a side. Look at my second triangle, angle, angle, side. So these two triangles would be congruent by angle, angle, side. So moving on to the next page in your workbook, let's look at some extra practice problems. On the right, I wrote my list of all the theorems. We now know 5. Side, angle, side, 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 HL, which is only in rights, but not their only option, angle, angle, side, and angle, side, angle. So we're going to do the same thing we did yesterday, and we're going to look at the 2 triangles provided and decide if they can be shown congruent. Keep in mind our always true box. Our always true box, right now we're thinking about reflexive and vertical angles that are congruent. So number 1 gives us triangle GHK and triangle JKH, and we are to decide if there's enough information to prove that the 2 triangles there are congruent. If you look at the triangles, if I trace my pen, I have an angle marked, then an angle marked, and then a side. And the exact same thing happens on this one. So I would say yes, these 2 triangles can be shown congruent by angle, angle, side. Number 2, we have triangle ABC and DEC. Again, we need to notice here the markings that are there. Are the corresponding positions congruent? And if they prove one of these 5 theorems on the right, then we can say the triangles are congruent. Angle B is congruent to angle E, C to C, and BC is congruent to CE. And if you notice, that makes these 2 triangles congruent by angle, side, angle, angle, side, angle. So we would say yes, there's enough information by angle, side, angle. And these 2 examples did not have to use any of the always true statements. All the markings were there. If you look at number 3, we have triangle JKL and MLK. If you notice here, I'm going to first highlight those triangles. So triangle JKL in blue, and then triangle MLK, oops, that was supposed to be red, in red. Okay, so if you notice here, I have these 2 triangles that I'm trying to prove the big ones, and a lot of what people would see, and I'm going to erase that now that we know it's the 2 big triangles, a lot of people would see, well, there's vertical angles here, so I've shown the triangles. But that would mean we were looking at these 2 smaller triangles, and that's not what we want. So the vertical angles is not going to help us for this proof. What we can notice is that both sides are using KL, or excuse me, both triangles are using KL, so that is congruent. But we still don't know if the triangles are congruent by one of these theorems. So this one would be no, not enough info. And number 4, we have triangle RST and triangle UVW. If you notice there, they have right angles, so we should automatically check HL. Is it HL? Well, I have the hypotenuse on each of them is marked congruent, VU to RS, but they're not conjoined. We don't know if the other legs are going to be congruent or not. But what we do have is an angle there in the middle. So each triangle has angle, angle, side, angle, angle, side. So yes, this would be true by angle, angle, side. And even though it's right, we can still use another theorem. Next, let's look at number 5. It says we have to decide, given the congruent statement here in the directions, if we can decide that the triangles are congruent or not, based on the characteristics given. So we have to explain that. If there's not a picture, what I suggest is draw one. So I'll draw triangle L, M, N, and then triangle P, Q, R. Notice I put the corresponding positions in the same spots. So 5 says, I'll do 5 in blue, it says M is congruent to Q, N is congruent to R, and NL is congruent to RP. So NL is congruent to RP. If you look at those 2 pictures that we drew, and we do draw the pictures when it's not drawn for us, we have angle, angle, side. So we would say yes, or angle, angle, side. And the picture would be part of my explanation. I will take pictures. Okay, so for number 6, I'm going to draw those 2 triangles again because I'm using the same one. So I've got LMN, and I've got PQR, and I'll mark these in green. It says L is congruent to R, M is congruent to Q, and LM to PQ. LM to PQ. So if you look here, on triangle LMN, I have an angle, side, angle, and that's great. But if you look over to the other side here, I have a angle P is the one that is supposed to be, if you look back up here to the congruence statement, P and L are in the same position. So if L is marked, the one that is congruent to it, or should be, if they are congruent at all, should be P. So this one would be no, not congruent. And your picture would be a good enough explanation showing me that the corresponding pieces were not congruent. Moving on to the next page, we're going to go to number 7. It says to write a proof using ASA, congruence. In a proof, whether you're doing a chart or a paragraph, you always start with your given. So go ahead and take a moment and write your given. AC bisects angle DAB and angle DCB. So then I'm going to look at my picture because I need to mark it. Because remember, when you're given the given, you might have a marking to make out of it, and it's whatever you mark, that's what you write. Since it says AC is bisecting angle DAB, I'm going to find angle DAB, and that means it's cutting this angle in half. So what I have found from this is that angle DAC is congruent to angle BAC by definition of bisect. And then if you look at the next statement, it also bisects DCB, and that's this angle right here. So it's actually cutting that one in half too. So that means that this angle is congruent to this angle. So angle ACD is congruent to angle ACB, also by definition of bisect. So then I look at that picture, and it says in the directions I have to use ASA. So then I think back to my list of the things that are always true. Are there vertical angles? Is there reflexive? Is there something they have in common? What I should see is side AC, and I can say that AC is congruent to AC by reflexive. And because I'm running out of room, I'm going to go right up here. So I mark that. So now I can say the two triangles, ABC is congruent to triangle ADC by angle, side, angle. And our last proof for today is number 8, and it says we have to use angle, angle, side. So really we're focused on the triangles here, even though the circle is there. So I'm going to write my given. O is the center, as well as angle N is congruent to angle P. So I'm going to make sure that that is marked. My angles are marked. What does O as the center mean? That means that any line drawn from the center to the outside of the circle is going to be congruent. So I can automatically, from that first statement, say ON is congruent to OQ, as well as OM is congruent to OP. Why? Because O is the center of the circle. Now, this is where you really have to think back to what we've learned about triangles. If you look, and I'm highlighting the triangle in green here, in green here, both sides are marked congruent. What does that mean about base angles? That means that if two sides are congruent, the base angles should be congruent as well. So I have all of these marked congruent, so I can automatically assume that angle M is congruent to angle N, and angle P is congruent to angle Q. Why? Because the definition of isosceles triangle. So from that statement, I notice that the corresponding position, since all the angles are congruent, I can prove that these two triangles are congruent as well. So if you notice, I can prove angle, angle, side, angle, angle, side. So triangle MNO is congruent to triangle PQO by angle, angle, side. This was a little bit of a harder proof, and you could have taken it a few steps further, but I stopped here because it